So we're going to look at how ionic compounds behave in two liquids. The first one is water, the second one is paraffin. Now we've got 4 ionic compounds here. I'm hoping you can see them on the screen. This blue substance here is copper sulfate. This is potassium chloride, you can see KCl written on the pot. This is magnesium oxide, and this is sodium chloride, NaCl. You can see the formulas there. Now what I'm going to do is I'm going to put a couple of spatulas of each one into a boiling tube. Use a different spatula for each one. 2 spatulas of each into a boiling tube. And then I'm going to add volume of water. And finally the two spatulas of each into the sodium chloride. So what I'm going to do is I'm going to add 20 centimetre cubed of water to each boiling tube, measured in a measuring cylinder. And as you can see, I've done the previous 3, that's to the copper sulfate. Stoppers on each and shake for 5 minutes. Now obviously we shake these for the same amount of time, but the results will be the same. I might have said 2 minutes in your book rather than 5 minutes. I'll shake them up and see whether they've dissolved. Now around page 20, 21 in your booklet, you should draw a table to see whether they've dissolved or not. Now if we start with the same order, copper sulfate, you can see has dissolved, so that's soluble. Potassium chloride has dissolved, that's soluble. Magnesium oxide, still an ionic compound, not as soluble as the others. And sodium chloride has dissolved. You can say that most ionic compounds are soluble in water. We repeat exactly the same now for paraffin. So I've done exactly the same now, this time, but using paraffin. Paraffin is an organic liquid. It's a fuel, but it's a different type of liquid to water. And we're going to see whether these ionic compounds dissolve in paraffin. And again, I've got my copper sulfate, my potassium chloride, my magnesium oxide and my sodium chloride. And again, it's just a matter of shaking them for a couple of minutes to see whether they dissolve in the paraffin. You can see the paraffin is a much gloopier, thick liquid. But it's whether they dissolve in paraffin. And you can actually see that they do not dissolve in paraffin. Okay, they dissolve in water, but they do not dissolve in paraffin. Magnesium oxide doesn't really dissolve in water very well, and certainly doesn't dissolve in paraffin. Okay, so ionic compounds, most are soluble in water, none of them are soluble in paraffin. They are insoluble in paraffin. So we've got the ionic compounds dissolved in water here, the solutions. Same order, copper sulfate, magnesium oxide, sodium chloride. They conduct electricity. Now I've got a power pack here, 2 leads and a bulb, and 2 electrodes. You've used electrodes before. If I put the electrodes together, the bulb lights. And we're going to see whether each of these solutions conducts electricity. There's my copper sulfate. There's my potassium chloride. There's my magnesium oxide. So just pouring them into beakers my sodium chloride. So when I put the electrodes in, if the bulb lights, it conducts electricity. So I'll bring my power pack over. You can still see the bulb. Into the copper sulfate, you can see the bulb lighting up. Into the potassium chloride. Again, you can see the bulb lighting up. Don't touch the electrodes, but you can see the bulb lighting up. Into the oxide. The bulb lights up, even though not much magnesium oxide dissolves, some does, so it will conduct. And the sodium chloride. Okay. Now, all ionic compounds in solution will conduct electricity. The ionic compounds that we try to dissolve in paraffin wouldn't conduct because they haven't dissolved. So ionic compounds do not dissolve in paraffin. They do dissolve in water, and if you tested ionic compounds as solids, so I've got potassium chloride there, and just put the electrodes into there, the bulb doesn't light because ionic compounds do not conduct electricity when they're solid. They do conduct electricity when they're in solution.